Now let us deduce the condition for symmetry in terms of Z parameters. To do this, first let us understand what is a symmetrical network. A two-port network is said to be symmetrical if the ports of the two-port network can be interchanged without changing the port voltage and current. That means the port voltages and port currents remaining same if port 1 and port 2 are can be interchanged. If they can be interchanged, then the network is said to be symmetrical. So see what actually it means. Mathematically it means, suppose I apply a port current by port voltage, a voltage source at port 1. Vs is a voltage source applied at port 1 with port 2 open. So I2 is equals to 0 and V1 equals to Vs. If I2 is equals to 0 and V1 equals to Vs, then Vs by I1 will be equals to Z11. So that is what I have written. Vs by I1 is equals to Z11. Again Vs is applied at port 2. Vs is applied at port 2 with port 1 open. So I1 is equals to 0 and V2 is equals to Vs. So with I1 is equals to 0 and V2 equals to Vs, Vs by I2 will be equals to Z22. So if the ports can be interchanged, then what it means without changing the port voltage and current, then what it means? It means that Vs by I1 must be equals to Vs by I2. So Vs by I1 is equals to Vs by I2 is the condition for symmetry of a two-port network as per the definition of a symmetrical two-port network. So Vs by I1, that is Z11 should be equals to Vs by I2. So this will be I2. Make a correction in your note. Vs by this will be I2. So this is Vs by I2. So that is Z22. So if these two are equal, then Z11 is equals to Z22. So that is Z11 equals to Z22 is the condition for symmetry of a two-port network in terms of Z parameters, right?